Viewfinder. It's a game launched in 2023 July that has piqued my attention. It has some very awesome and mind-blowing mechanics. Today I will talk about a Polaroid camera that can capture reality by replicating the objects depicted in your photos. The game have others good mechanics that complement this. Although I really like of puzzle games like this, unfortunately I'm poor and at the moment I cannot buy the game. So I decided to make the game myself. First, we need to know what objects are in the range view of camera. For this, I used a concept called frustum planes, that basically are the region of the space that is visible to camera. That region is defined by a set of 6 planes that in basic words represent the 4 main sides, right, left, top and bottom, and the min and max distance that the camera can render, near and far. Fortunately, Unity already have a function that return that set for us, so we don't need to care about that. The Unity planes have a positive and a negative side. The part of the mesh that will keep intact will be the one in positive side, and the other one will be discarded. To know what objects are in the frustum, I used the bounds of the renderer and the function test planes AABB, that return if the bounds are inside of the set of planes, and even though it returns false positives, it's the better this way. The mesh of these will be cut even, so it's not a real problem. To know how to cut a mesh by 6 planes, first we need to know how to cut it by only one plane. I will represent this in 2D with a line instead of a plane, but the logic it's the same. There are 4 cases that we have to care about, when 3, 2, 1 and 0 vert are in the positive side. When all verts are in the positive side, obviously we have to keep they intact, and I say the same for they normals and UVs. In the same way, when all verts are in the negative side we discard all. When only one vert is in the positive side, we have to cast 2 rays from this point to the direction of the other points, and check the intersections with the plane. Again, Unity help us here with the method plane.raycast, that give us the distance along the ray until the intersection point. Unlike the physics raycast point method, we cannot get the intersection point directly with a raycast hit, but with the ray.getPoint, we can have the point at certain distance in the ray. Since we have the distance between the vertices and the distance from the positive vertice to the intersection points, we can find the ratio of what UV chords each point must have. We'll use it to do a lerp between all UV's channels. Remember that the baked light map usually stays on channel 2, so try to interpolate at least the first 2 channels. The normals for the intersection points can be just a copy of the normals of the vertice in positive side. Now, save the data of the old vertice, save the data of the new vertices and save a triple of each vert index to the triangle list. Take care about the order, because Unity uses clockwise order to draw the triangles. When 2 verts is in the positive side and only one is in negative, we have to cast 2 rays from each of the point in the positive side to the direction of the negative one, the inverse of the previous step. Again, check the intersections with the plane.raycast, ray.getPoint blah blah blah, finally the new positions of each new vert. Save the data of each vert like the previous step, but now save 2 triples in the triangles list, because there are 2 triangles now. Again, take care about the order and the index that you save. Repeat it's for all planes. To fill the roles that has been created by the cut, you will have to get all new verts, intersections, group them if they form a polygon, and make a polygon triangulation algorithm like ear clip or Delaunay. I'm lazy so I did a fan triangulation. It's clearly a bad idea because it depends of a special cases, but that it will do. So for you don't end up cutting the objects that are already in the scene, create a new game object. I will name it instances copy, set its position and rotation to be exactly the player's, make a copy of each of the objects to be cut, all that is in the frustum, and set the instances copy as parent of these copies. After that, set instances copy as inactive. Mesh manipulation, it's a little hard for CPU do in a single frame, so you can start a coroutine or a job that will be cutting the meshes while you can't see and place the instances copy. When you want to put the photo, just set the instances copy as active, and set its position and rotation to the players again. And that's it. There is one more feature, that is to cut the objects where the new objects will be placed, but I don't find a satisfactory way to make this without increase the number of triangles, but which remained with a minimal FPS drop. Maybe I will do it later, optimizing it in an async way, but I don't have much time these days, so it's more likely that it will stay that way. But the source code will be in description, so you can implement this by yourself.